let's look at data from 20 randomly chosen workers in downtown Concord. And again, we're looking at commute times in minutes. So we have our data set of 20 commute times here, and we're going to again find the median by starting with a StemPlot. So in the Concord data set, the minimum is 5 minutes. There's 2 workers who have a 5-minute commute, and the maximum is 55 minutes. So when we set up our StemPlot, our stems go from 0 to 5. Essentially, we're counting by tens. So we are going to go ahead and put our data in here. The commute times that are 5 minutes and 6 minutes go in the first row. So no tens, 5 minutes, and 6 minutes. Then the commute times that range from 10 to 18 go in the second row with the tens, and so on all the way up to 55 minutes in our max. So we want to find the median. So we are going to find the middle of this data set. So the middle of this data set is again between the 10th and the 11th data points because we've got 20 commute times. So if we say 20 divided by 2, we get 10. We know an even data set, the median is going to be dead in the middle. So it'll be between the 10th and the 11th commute time. So you can start at either the minimum time or the maximum time and count in on your StemPlot and find the middle should be here where I've drawn my arrow. And in this case, it's between 18 minutes and 18 minutes. So we know the median is going to be the averages of those two values, or 18 minutes. The median isn't either one of those data points, however. It's a fence in between. So there's still 10 numbers below the median and 10 numbers above the median. When you have an odd data set, there's just one median. But if you have an even data set, you have to average 2 numbers, and the median is more like a fence, not an actual part of the data set. So now we're going to go into StatCrunch, and let's check the StemPlot in StatCrunch and see how it looks in StatCrunch and then find the mean. So in StatCrunch, I'm going to exit out of my commute times from San Francisco. I've got my Concord commute times in a column, and I'm going to go to Graph, and I'm going to choose Stem and Leaf Plot, and just take a look at how StatCrunch makes the Stem and Leaf Plot for the Concord commute times. So I choose Concord commute times that I've entered in StatCrunch, and then I want my leaf unit to be the ones place, and I don't want to trim any outliers, so I'm going to select none here and head over to Compute. Now, StatCrunch has done something a little different than I did when I drew my StemPlot by hand. Because I have larger data sets in the 10s and the 20s, StatCrunch has gone ahead and split the stems. So when they split the stems, the ones places between 5 and 9 end up in one row, and the ones places between 0 and 4 end up in another row. So for example, our commute times in the tens place went from 10 to 17. And so what StatCrunch has done is taken the lower values and put them in the first row of the ones here. So this would be any values from 10 to 14. And then the higher values from 15 to 18 have been put in the second row. StatCrunch has done the same split for the 20s and the 30s. Notice there's no values from 35 to 39, so we just leave a blank there to show the data spread out. And similarly, in the 40s, there's no lower values, so it's blank there. When you draw your stem plots by hand, it's your choice. You can split stems like StatCrunch does. You can draw all the values in one row. If you think about it as a histogram, this is sort of just a histogram, but with bin size 5. So if we look at a histogram for this Concord commute time, and we start at 5 and make our bin width 5. So we start at 5 and make our bin width 5, and then we go ahead and say compute. This looks just like a rotated version of our StemPlot. If we wanted to count by tens, we can go Graph, Histogram, and choose Concord commute times. Make our bin width 10, hit compute. This now looks like the StemPlot where the 3 values, 5, 5, and 6 minutes are here, And then all 8 values from 10 to 19 are in the next bar. So depending on your bin size, you can construct bin width 5 or 10 to have your stem plots look similar to your histograms. We came into StatCrunch to find the mean, so let's go ahead and do that. Stat, summary, stat, columns. We'll choose conquer commute times, and then we want to see the mean. And go ahead and hit compute. So our mean here is 22.4. So remember, our median was 18 minutes, and our mean now is a higher value. So when we compare, we can say the mean is larger than the median, which is another way of putting the mean on the higher side of the lesson inequality. You could similarly interpret this by saying the mean is smaller than the mean. The median is smaller than the mean. So you could say the mean is larger, or you could say the median is smaller. Either way, it's the same explanation. So if we look at the histogram, it has a right tail. So if we head back into StatCrunch, whether we're looking at the histogram with bin size 5 or bin size 10, we see the skew is out to the right. The peak is early on the left side of the graph, and the skew comes down to the right side. If we look at the stem plot and rotate our stem plot, we see the same relationship. The tail is coming out to the higher values. So we say it's a right tail relationship or a right tail distribution. So the relationship we see here is that if you have a right tail histogram, a few high values pull the mean up. So when we have a right tail scenario, we say the median is less than the mean.